Okay, now concentrate here. What I say that in this LVDT, the two windings are there, one primary winding and two secondary winding. So that's why here I have written S1 and the S2. And these two secondary windings are connected in a series but in opposite end. बघा ते कसं connect केले. And from these two terminal, we will get the output in the form of electric voltage. So we know that as the primary winding is connected to that AC source, so definitely the alternating current is flowing through the primary winding. This alternating current in the primary winding create the alternating magnetic flux, and this alternating magnetic flux will link with the both the secondary coil, and according to the Faraday's laws of electromagnetic induction, EMF is induced in both the secondary coil. EMF induced in a coil S1 is, I say that E1, and EMF induced in a coil S2, I say that it's a E2. And as we know that these two secondary coils are connected in a series but in opposite end, so that resultant output voltage, it becomes E1 minus E2. Because as it is connected, why I have not added these two voltage, though it is connected in series? Because here the two inductive coils are connected in series but in opposite end, so that output voltage, it becomes E1 minus E2 is there. And now this is a movable soft iron rod. Soft iron rod. So the position of this soft iron rod in the core will decide the how many voltage is generated in two secondary coils. Now try to read it. When primary winding is excited by that AC current, it produces alternating magnetic field. The alternating magnetic field induces voltage in both the secondary winding depending upon the position of a core in that halo former. Output at the secondary of the coil S1 is E1 and the coil S2 is E2. So the differential output, I say that it's a differential, name itself, it's a differential output. The differential output, it can be calculated by E1 minus E2 is there. Now see that what happened. Now, according to the position of this halo cylinder, okay, if suppose this halo cylinder is at a one position, and because of that, whatever the magnetic field produced by the primary winding, if the same magnetic flux will link with the both the secondary coil, then definitely EMF induced in a coil S1 and EMF induced in a coil S2 are equal. Because of what? आता जर आपण असं अज्युम केलं की हा जो काही सॉफ्ट आयर्न कोर हा एकदम मिडल पोर्शनला आहे, मग मिडल पोर्शनला असल्यामुळे काय होणार, ही प्रायमरी वाइंडिंग जेवढा फ्लक्स तयार करेल, हा फ्लक्स या सॉफ्ट आयर्न कोर मुळे या दोन सेकंडरी वाइंडिंगला इक्वल फॉर्म मध्ये लिंक होईल. मग जर फ्लक्स लिंक विथ बोथ द सेकंडरी कॉइल, इफ इट इज इक्वल, then EMF induced in both the coil is also equal. So what is the resultant output? As the resultant output is E1 minus E2, so the resultant output, it becomes 0. So the position of this core is called as a null position. Why it is called as a null position? Because it gives the output voltage, differential output voltage is a 0. Now try to read it. When the core is at a null position, means for no displacement. आता हा आपला स्टार्टिंग पॉइंट आहे की आता या ठिकाणी आपण जो कोर ठेवलेला आहे म्हणजे त्याची डिस्प्लेसमेंट काहीच नाहीये, म्हणून तर आपल्याला आउटपुट व्होल्टेज काय मिळतंय, 0 मिळतंय. Null position, we call it a no displacement of the core. When the core is at a null position, then the flux linking with both the secondary winding is equal. So the induced EMF is equal in both the winding. So no voltage is developed. No voltage is developed, so that output voltage becomes 0 here. Get it my point? So that output voltage is not there. So this is called as a null position. Now the second position. आता middle म्हणजे आपला initial stage होती. Now when I say that the core is moved towards the left position of the null position, towards the left hand side of the null position. मग आता कोर जर लेफ्ट हँड साइडला मूव्ह झाला तर काय होईल की प्रायमरी वाइंडिंगला जो काही अल्टरनेटिंग फ्लक्स तयार केलेला आहे तो फ्लक्स या कोर थ्रू S1 ला मॅक्सिमम लिंक होईल. आता इथं डायग्राम मध्ये तुम्हाला दिसेल बघा, S2 ला पण लिंक होईल, बट ऍज कम्पेअर टू दॅट S1 I say that the maximum flux it can be linked with the coil S1 because of the movement or the displacement of this core is there. And as the maximum flux it will link with that coil S1, so the EMF induced in a coil S1 is greater than the EMF induced in a coil S2. So that E1 is greater than E2, so definitely we will get the positive supply here, or the positive output voltage is there. And then third case is that if the core is moved towards the right hand side of the null position. So when the core is moved towards the right hand side, the maximum flux it will link with the coil S2 as compared to that S1. So in this case, I say that E1 is less than E2. E1 is less than E2. So definitely you will get the negative output voltage is there. Means here you can observe that the three cases, the middle portion, it gives that the output 0. Left hand side, if the core is moved towards the left hand side, you will get that positive output. If the core is moved towards the right hand side, you will get that the negative output is there. It means that the position of this core will decide the output voltage is there. And now you can try to see that the one video so that you will get the idea or your concept will be clear here. Give me 1 minute.
Explain the construction.
All of you please have a focus on it.
And working of LVDT. LVDT is also known as linear variable differential
Is it audible?
Yes, sir.
transducer
Yes, sir.
or transformer. It is a passive transducer which measures displacement. It consists of a primary coil wounded on a hollow cylindrical rod and is connected to the AC source. It also consists of two secondary coils having equal number of turns and is wounded on a hollow cylinder at equal distance on either side of the primary coil. The two secondary coils are connected with each other in series opposition, so that the net induced EMF of the two secondary coils becomes, we see that a movable soft iron core is placed inside a hollow cylinder. Position of this core with respect to the two secondary coils will affect the magnetic coupling between the primary and two secondary coils. Let's now understand how this LVDT works. We see that when an AC source is activated, alternating current starts flowing through the coil, due to which varying magnetic field is produced. Now when this varying magnetic field interacts with the secondary coil, an EMF is induced in the two secondary coils. We see that initially the core is placed in such a position that equal EMF gets induced in both the coils, due to which the net EMF of the two secondary coils becomes 0. This position of the core is known as null position. Now if we move the core towards the right, we see that the flux linking with coil S2 becomes greater than the flux linking with coil S1. As a result, the EMF induced in the coil S2 becomes greater than the EMF induced in coil S1, and the net EMF shows a negative value. Similarly, if we move the core towards the left, we see that the flux linking with coil S1 becomes greater than the flux linking with coil S2. As a result, EMF induced in coil S1 becomes greater than the EMF induced in coil S2, and the net EMF shows a positive value. Thus, LVDT uses the magnitude and polarity of the net EMF induced to measure the displacement of its core from the null position.
Okay, so with this LVDT, only one type of a transducer we discuss. Today we stop here, and from the next lecture, we will try to discuss that the few more type of a transducer here. Okay, so today we stop here. Thank you.